Hello, I am Nandavardhan Reddy. This is a video demonstration of our project Viber Mechanism as a part of the course Mechanism Sessional. My team consists of three members, myself and Sheikh Samir and Manideepu Reddy. The goal of our project is to synthesize a 4-bar mechanism with a with a Viper and optimize it. For example, in our project, we did optimizations to increase the sweeping area, and also we were able to move the Viper at higher velocities at some parts of its motion. Viper mechanism is a 4-bar crank rocker mechanism. The motion of the crank provides symmetrical motion, that is, forward and backward strokes are identical. Here we can see that the degree of freedom is 1. The left side video is the Viper mechanism done according to the values given in the previous tutorial. We can see the wiping region is being drawn, and the right side video is after we optimized it, and we can clearly see that the swiping region has been drastically increased after optimization. The wiping area it depends on many factors such as configuration of the ternary link, lengths of different bars. If we can maximize angle between two extreme configurations, that is the main idea behind increasing the swept area. Decreasing length of input link decreases the swept area. Decreasing length of output link increases the swept area. Now I'm passing on to Manideepu Reddy.
Hi, this is Manadip Reddy. I will be showing the Viper mechanism in the linkage software. These two curves here like shows the uh, curvature, like curve traced with the 2 points of the Viper. And let me simulate the mechanism here. In the mechanism, we can see one of the extreme position here uh, as I point my mouse here. And the another extreme position can be seen here. So this is the overall simulation, and I have imported the velocity profile of both the points F and H. So actually, the velocities of these both are same, and I plotted this velocity profile in the Python notebook. So I have imported the CSV file here, and this is the velocity distribution of the Viper points here. So we can see there is a periodicity in the velocity. Let me show the minimum velocities and the maximum velocities from the plot. So at this one end, like it is approximately 0 here, and the maximum velocity is nearly 276. And like I approximately calculate the acceleration by taking the difference in the velocity instance. This may not be to the perfect scale, but this is the approximated graph of the acceleration. Coming to the innovation, in this part, like we have changed the input link to the slider. So our mechanism changed from 4R to 3R1P. This is due to the fact that length of the input changes periodically. Uh, on one part of the circle, like half circle, the length decreases, and other half of the circle length increases. This mechanism gives different velocity distribution and in different off cycles. So let me show you the new mechanism in the linkage software. So this is our new linkage software, new mechanism. So let me simulate it. You can see that the length of the input is increasing in the off cycle, and in other half the length of the input link is decreasing. So uh, in the process, in the one direction, the velocities of the slower side or the slower range. In the other direction, the velocities are of the higher side. So coming to the velocities of the points F and H in this case, as we expect that like the velocities on one cycle has the maximum velocity of 90 mm, 174 meter per second. In the other direction, the maximum velocity is nearly 450, like which is of higher side comparing to the mechanism that you have seen in the earlier case. Now I will be passing to Samir for further implementation of the mechanism in the MATLAB.
Hi, myself Sheikh Samir. Now, I am going to briefly explain the MATLAB code and the stimulation of the Viper mechanism in the method. So, let me run the code. So, you can see the Viper mechanism, and the sky blue area is the swept area by the Viper. So, let me briefly explain the code. The section 1 of this MATLAB code tells different lengths of the Viper mechanism. So, we initialize these lengths, which are the parameters, and the respective angles of the modified Viper. Here, the theta is the angle of the crank with respect to the x-axis, and we initialized the angle of the crank with respect to x-axis as 50 degrees, and we went with a variation of 360 degrees, and so it goes to 410 degrees. And next, coming to the second part of the MATLAB code, we run from 1 to 360 degrees, and we found the different angles of the links in the Viper mechanism, which will be helpful in calculating the coordinates of the Viper. So after finding the coordinates of the Viper, these all comes into a different frames, and these frames gets added up and form this swept area in the Viper diagram. Coming to the third part of the MATLAB code, we have done the plotting and the animation. In this plotting, we have given colors to different links present in the figure of the Viper as shown. So firstly, we initialized the angles of different links present in the Viper mechanism, and then we plotted each frame of the Viper mechanism with change in angle of 1 degrees, and it goes up to 360 degrees. So at last we have deleted the previous plottings, and we went back to the initial position of the Viper. So at last this is the Viper sweep area, and next, and we can find the Viper swept area, which is the sky blue color. So thank you.